Hello, welcome back to the channel. Let's solve another problem. That's the very first problem in the LeetCode. That's a two-sum problem. This is the most liked and one of the most asked problem in the interview settings. So let's see what we are being asked. So we are given the two integer. Now we are given an array of integer nums, an integer target, and we need to return indices of the two numbers such that they add up to target. And we may assume that each input would have exactly one solution, and we may not use the same element twice, and we can return the answer in any order. So let's see let's understand with the example. Let's say the 15, 7, this is a nums array, and 2 and 11, and we are given the target 9. We need to find the indices of two numbers, two elements in the array, such that they need to add up to target. Let's say for the first one, this is if we just 7 plus 2, they add up to 9, right? So basically the element of 7 is 1, the index, right? And the index of 2 is basically 2. So we need to return 1 and 2, or 2 and 1, right? So we can return in any order. So basically this is the problem statement, right? So we are being guaranteed that there is exactly one solution that exists in the array, right? So let's see what's the brute force approach for this problem. So what we can do, we can start iterating, let's say 15, 7, and 2, and 11. We start iterating from the first element, right? Then let's say for the 15, right? 15, and check if 9 minus 15, which is minus 6, right? If minus 6 exists in the remaining part of the array. Basically, we check that minus 6 does not exist on the remaining part of the array, right? This is the 0, 1, 2, and 3. Basically, for the first element, we check from the next element for the remaining of the array, and if it does not exist, then we go check for the second element, right? And from here, then if we just go to 7, the next element, then 9 minus 7 is basically 2. Then we check for 2 in the remaining part of the array, right? And in this case, and see if that 2 exists in the remaining part of the array. Yes, and it exists. Then we can immediately return 1 for the index of 7 and 2 for index of 2, right? This is the array. So basically right now we are iterating for array twice, right? Initially we are checking for 15, and the difference we are checking in the remaining of the array. We are checking for the 7, and we are checking for in the remaining of the array. Then if it exists, then we return this index. Otherwise, we are guaranteed there is one solution. But the time complexity of this is of n square, right? Basically, we're doing this, iterating this for the entire array twice, basically, right? For the code, we can see this is the brute force approach, and we check we iterate from I for the entire length. If then for the next element, we I plus 1 up to the remaining part of the array. If the nums I plus nums j is equal to target, then we return ij. Basically, this 15, right? And the 15 plus 7 if is equal to 9. No, Then 15 plus 2, is that equal to 9? No. 15 plus, we check for each array, we check everything in the remaining part of array. And if they are equal, then we return the index of I and j, right? This is the brute force approach, and it's a n-square approach, and it's not optimal. So what can we do to improve this this approach, right? The second one is sorting, right? Sorting is basically we are given this again, let's say same array, 15, 2, 7, and 11, right? So if we sort this, sorted 2, 7, 11, and 15, right? So if after sorting, the first approach is like we basically iterated before sorting and we did the linear search, right? After sorting, what we can do, we can apply the binary search, right? The sorting is basically, it takes n log n. And after sorting, then we can search this, not in the upper, in the first approach, we did the linear search. And after sorting, we can use the binary search, right? Binary search. So for binary search, basically for this one, and it will be basically dividing this into the 2 element, and binary search basically 2 pointer, right? We can just search in the leftmost left half of the sorted array, right? And this binary search is basically log of n, and time complexity will be basically n log n plus log n, right? So this is basically the improvement, and we can say n log n approximately, right? In log n approach. This will be much better than our brute force approach and square, right? And this one is the code for the binary search. Here we do initially sorting, right? The sort for the array. Then we iterate in through the sorted array. Once we check this first element, and we just look at the 2 pointer in the remaining half of the array of the sorted array, right? And this part and this part will be n log n. This binary search part will be a log n, right? So this is the improvement to our brute force approach. But is this the most optimal solution? So let's see. So we can the next the most optimal approach will be third one is basically hashing, right? Or dictionary, right? Or the hash map, right? Hash map. What do we do in this approach? So in this approach is basically initially we create a hash map to be empty. Then what we do, we say this the same array 15, 7, 2, and 11. Then each element, they will have their index, right? 0, 1, 2, and 3. What we do, we look at we iterate from the very beginning, right? This is the hash map. Let's say hash map. We say basically, and we check for the first one if 15, if this target minus 15 will be what? let's see, target minus 15, 9 minus 15, if it is in the hash map, which is minus 6. If it's not in the hash map, then we add this hash map, this number, this element into the hash map. Then we also store its index, right, which is 0, right? Then we go to the second one, second element, and 7, and 9 minus 7, if it's in the hash map, let's say it's 2, right? If it's in the hash map, we see. If it's not in the hash map, then we add this in the hash map, right? So 7 we store as 1 because index is 1, because initially we didn't find it. Then we go check, right? We go check at the next element, 9 minus 2, which is 7. Is it in the hash map, right? If it's in the hash map, then what's the index of this 2? Index of 2 is 2. And index, then we also check for the 7. What's the 7? We, in the hash map, we say hash 7, it returns to 1, right? Basically, we just concatenate to this string. Basically, we found the 9 minus 2 is 7, and it already exists in the hash map, and we get the value of this dictionary at the key 7. Then we just add to here, right? And we, at the end, we just return 1 or 2 or 2 or 1. It doesn't matter. In any order we can return. So so this is a code. Initially, we initialize the dictionary of integer. We enumerate the nums array to get the index and the num, right? Then we check if the target minus that number is in the hash map, right? If it's in the hash map, we know the index, we return this one, and we get the hash map target minus num, which is target minus num. Let's say if the target is 9 and num is like 2, which is 7, right? We just get 7, and hash map of 7 at 7 at key 7, it will be 1. So we basically return that number. If that's not in the hash map, we add this in the hash map in the case of 7, right? So basically, in this case, time complexity will be O of n, because we are iterating the nums array only once, and space complexity will be at most of O of n because of the hash map, right? So that's it for this problem. I hope it's clear. And so here we discussed 3 approaches. The first approach is brute force, the least optimal approach, where we are just iterating this array twice and doing the linear search. And the second approach is the sorting, so we can sort the array, and after sorting we can use the property of the sorted array and to do searching, which is the binary search, and it improves this time complexity n of log of n times log of n. And this is a kind of improved approach, but the most optimal approach is using the hash map. That's where we're using the hash map to track the elements that we have seen so far and return. And in hash map, we store that element as a number, as a key, and its index as a value. And at the end, we return if we find the difference in the array. We just simply return the value and index of that element in any order, right? So, and the time complexity is the most optimal time complexity will be the log of n, O of n, and the space complexity of O of n because of the hash map that we are storing. I hope this explanation is clear. We discussed all 3 approaches, and please, if you like this approach on the using the whiteboard approach and discussing all of the time and space complex. So please share your comments and let me know what you think. And see you in the next video. Thanks. Bye.